How did a narrow strip of fertile land surrounded by desert become the birthplace of one of history's longest-lasting civilizations? This documentary examines the archaeological and environmental evidence behind the formation of ancient Egypt along the Nile River. We'll distinguish between established facts, scholarly interpretations, and areas where researchers still debate. No dramatization, just the evidence as it stands today. One seasonal flood pattern that made agriculture possible in an otherwise barren landscape. One gradual shift in climate that transformed the Sahara from grassland to desert. One series of innovations in irrigation and grain storage that allowed scattered communities to become a unified kingdom. The story of Egypt's formation isn't about sudden miracles or mythical founders. It's about incremental adaptations over thousands of years, environmental changes, technological developments, and human responses to both opportunity and challenge. Stay with us as we trace the evidence from the earliest settlements to the emergence of pharaonic civilization, examining what the archaeological record actually reveals about how Egypt came to be. The Nile River is the world's longest river, flowing over 4,000 miles from the highlands of East Africa to the Mediterranean Sea. For ancient peoples, however, what mattered most was a 750-mile stretch through Egypt where the river created a narrow corridor of fertile land cutting through the eastern Sahara Desert. This wasn't always desert. Geological and paleoclimatic evidence indicates that between approximately 9,000 and 5,000 BCE, the Sahara experienced what researchers call the African Humid Period. During this time, the region received substantially more rainfall, supporting grasslands, lakes, and dispersed human populations. Rock art from the western desert depicts cattle herding and hunting scenes, confirming human presence in areas now uninhabitable. As the climate shifted toward greater aridity around 5000 BCE, populations gradually concentrated near permanent water sources, primarily the Nile Valley and Delta. The river's annual flood cycle became crucial. Each summer, monsoon rains in the Ethiopian highlands caused the Nile to overflow its banks, depositing nutrient-rich silt across the floodplain. This natural irrigation system replenished soil fertility without requiring complex technology. Archaeological surveys document increased settlement density along the Nile during this period of climate transition. Sites like Meramdom Beni Salama in the Delta and Badari in Upper Egypt show evidence of permanent villages with grain storage facilities, suggesting communities were adapting to sedentary agriculture focused on the predictable flood cycle. The geography created natural boundaries. Deserts to the east and west limited invasion routes and encouraged north-south communication along the river. Cataracts, rocky rapids, divided the Nile into distinct zones, with the area from the first cataract at Aswan to the Mediterranean becoming what we recognize as ancient Egypt. Understanding this environmental foundation is essential. Egypt's civilization didn't emerge despite its environment, but because of very specific geographic and climatic conditions that made intensive agriculture possible in an otherwise harsh landscape. If you're finding this exploration of Egypt's environmental origins helpful, consider liking this video and subscribing for more evidence-based historical documentaries. Your comments and questions help us understand what topics to explore next. Sharing this content supports educational material that prioritizes accuracy over sensationalism. The Predynastic period represents roughly 2 millennia of gradual development before the emergence of unified pharaonic Egypt. Archaeological evidence from this era comes from cemetery sites, settlement excavations, and material culture analysis. The earliest pre-dynastic phase, called Naqada I, approximately 4000 to 3500 BCE, shows communities practicing mixed agriculture, cultivating emmer wheat and barley while maintaining some hunting and fishing. Pottery from this period is relatively simple, with red polished surfaces and white geometric designs. Settlement patterns suggest small, largely autonomous villages. Naqada II, approximately 3500 to 3200 BCE, marks a significant transition. Archaeological sites show evidence of increased craft specialization, long-distance trade networks, and social differentiation. Decorated pottery becomes more elaborate, often featuring painted scenes of boats, animals, and human figures. Burials display increasing variation in burial goods, suggesting emerging social hierarchies. Some burials contain luxury items like lapis lazuli from Afghanistan and obsidian from Ethiopia, demonstrating trade networks extending well beyond Egypt. The appearance of cylinder seals, administrative tools used throughout the ancient Near East, indicates contact with Mesopotamian cultures. Researchers identify the emergence of regional centers during this period. Sites like Hierakonpolis in Upper Egypt show evidence of large-scale architecture, including what may be ceremonial structures. The famous Narmer palette, discovered at Hierakonpolis, dates to the very end of the Predynastic period and depicts what many scholars interpret as the unification of Upper and Lower Egypt, though interpretations of this artifact remain debated. Naqada III, approximately 3200 to 3000 BCE, represents the immediate prelude to dynastic Egypt. Archaeological evidence indicates increasing political consolidation, standardization of material culture, and the development of early hieroglyphic writing. Scholars debate whether unification occurred through military conquest, gradual political integration, or some combination of both. What's clear from the archaeological record is that Egyptian civilization didn't appear suddenly, but developed through centuries of social, technological, and political changes. The transition from mobile foraging to sedentary agriculture required specific technological innovations. Archaeological evidence reveals how ancient Egyptians developed systems to maximize the Nile's agricultural potential. Basin irrigation represents the fundamental innovation. Rather than allowing floodwaters to drain away, communities constructed low earthen banks to retain water in fields after the annual inundation receded. This extended the growing season and allowed crops to mature using stored moisture. Archaeological surveys have identified remnants of ancient basin systems, though many have been obscured by millennia of subsequent agricultural activity. Grain storage technology was equally critical. Egypt's climate, hot and dry for most of the year, naturally preserved stored grain if properly contained. Archaeological excavations reveal various storage methods: large ceramic vessels, pithoi, mud-plastered basket granaries, and eventually large-scale state granaries built of mud brick. The ability to store surplus grain for multiple years provided insurance against occasional flood failures and supported non-farming specialists. Botanical analysis of archaeological sites shows the primary crops. Emmer wheat and barley served as staples, supplemented by lentils, chickpeas, and later flax for linen production. Paleo-ethnobotanical studies examining preserved plant remains indicate that agricultural practices became increasingly intensive over time, with evidence of field preparation, weeding, and crop rotation strategies. Tool development followed agricultural needs. Early sickles used flint blades set into wooden handles. Plows, initially simple wooden implements pulled by humans, eventually utilized cattle for traction. The shadoof, a counterweighted water-lifting device, appeared later in Egyptian history but demonstrates ongoing refinement of irrigation technology. Scholars emphasize that agricultural surplus didn't automatically create civilization, but it did enable social complexity. Surplus production supported craft specialists, administrators, priests, and eventually a ruling class. The predictability of the Nile's flood cycle allowed for planning and coordination that would have been impossible with less reliable food sources. The archaeological record demonstrates that these technologies developed gradually, refined through generations of practical experience rather than sudden breakthroughs. Writing systems correlate with administrative complexity in ancient civilizations worldwide, and Egypt provides clear archaeological evidence of this relationship. The earliest Egyptian writing dates to approximately 3200 BCE, appearing on labels, pottery marks, and ceremonial objects. These proto-hieroglyphic inscriptions differ from fully developed hieroglyphic writing, but demonstrate the fundamental principle: visual symbols representing words, sounds, or concepts. Scholars debate whether Egyptian writing developed independently or was influenced by contact with Mesopotamian cuneiform, which emerged slightly earlier. Current consensus suggests that while the idea of writing may have been stimulated by awareness of Mesopotamian systems, the Egyptian script itself was an indigenous development. Early writing served primarily administrative and commemorative functions. Cylinder seals and stamp seals bore names and titles, allowing officials to mark ownership and authority. Jar labels indicated contents, origins, and sometimes tax or tribute information. Royal monuments displayed names and accomplishments of rulers. The development of hieratic script, a cursive form of hieroglyphics, made writing more practical for everyday administration. Archaeological evidence from later periods shows hieratic used extensively for letters, accounts, legal documents, and literary texts, while hieroglyphics remained the formal script for monuments and religious texts. Administrative development is evident in archaeological remains of early state structures. Seal impressions indicate organized storage and distribution systems. The appearance of standardized weights and measures suggests state involvement in regulating commerce. Royal tombs from the Early Dynastic Period demonstrate the state's ability to mobilize resources and labor on unprecedented scales. Scholars note that literacy in ancient Egypt remained limited to a small scribal class. Most estimates suggest literacy rates below 5% of the population. Writing served the interests of the state and temple administrations rather than facilitating mass communication. The archaeological record shows writing and complex administration developing together, each enabling and reinforcing the other as Egyptian society became increasingly centralized and hierarchical. The transition from multiple competing polities to a unified Egyptian state represents one of the most significant developments in ancient history, yet the precise mechanisms remain subjects of scholarly debate. Traditional Egyptian chronology, based on the Turin King List and writings of the Greco-Egyptian historian Manetho, credits King Narmer, also called Menes, with unifying Upper and Lower Egypt around 3100 BCE. The Narmer palette, discovered at Hierakonpolis in 1898, depicts a ruler wearing both the white crown of Upper Egypt and the red crown of Lower Egypt, suggesting unified authority. However, scholars debate whether this represents actual political unification or symbolic/ideological claims. Archaeological evidence indicates the process was complex and possibly gradual. Cemetery evidence from early dynastic Abydos shows increasingly elaborate royal tombs, suggesting centralized authority and resource control. The appearance of standardized pottery, architectural styles, and administrative practices across Egypt indicates cultural unification accompanying or following political consolidation. The Early Dynastic Period, First and Second Dynasties, approximately 3100 to 2686 BCE, shows evidence of state formation processes. Royal inscriptions record military campaigns, suggesting unification may have involved conquest. However, the absence of extensive fortifications or widespread destruction layers complicates purely militaristic interpretations. Memphis, located at the junction of Upper Egypt and the Delta, became the administrative capital. Its strategic location allowed control over both regions. Archaeological evidence from the Memphis area remains limited due to millennia of subsequent occupation and Nile silt deposition, but textual references and later accounts confirm its importance. Scholars identify several key developments during this period: establishment of royal succession practices, development of the Sed Festival, Royal Jubilee, emergence of royal titulary, the formal naming system for pharaohs, and construction of increasingly monumental royal tombs, culminating in the Step Pyramid. The archaeological record suggests unification created both opportunities and challenges. Centralized authority enabled large-scale projects but required sophisticated administration to govern a territory stretching over 750 miles along the Nile. The Old Kingdom, particularly the Fourth Dynasty, represents ancient Egypt at its most architecturally ambitious. The pyramids at Giza, among humanity's most recognizable monuments, demonstrate both technological capability and organizational capacity. The Step Pyramid at Saqqara, built for Pharaoh Djoser around 2630 BCE, marks the transition to monumental stone architecture. Previously, royal tombs were constructed of mud brick. The Step Pyramid, designed by the architect Imhotep according to later tradition, stands approximately 200 feet tall and introduced innovations in stone construction that subsequent pyramids would refine. The Great Pyramid of Khufu at Giza, completed around 2560 BCE, represents the apex of pyramid construction. Archaeological and engineering analyses reveal sophisticated planning. The base covers approximately 13 acres, with sides aligned to cardinal directions within fractions of a degree. Original height reached 481 feet, constructed from approximately 2.3 million limestone blocks. Scholars have extensively debated construction methods. Experimental archaeology and analysis of tool marks suggest copper chisels, stone hammers, and wooden sledges were primary implements. Recent discoveries of worker villages near pyramid sites, including Hayt el Ghurab near Giza, provide evidence about labor organization. Skeletal analysis of buried workers shows evidence of hard physical labor but also medical treatment and adequate nutrition, contradicting earlier assumptions about slave labor. Textual evidence and administrative papyri from later periods describe rotation systems where villages provided workers for limited periods, possibly during the inundation season when agricultural work was impossible. Current scholarly consensus suggests pyramid construction involved a permanent skilled workforce supplemented by larger temporary labor forces. The pyramids served as royal tombs, but also as statements of royal power and cosmic order. Pyramid texts, religious inscriptions appearing in later pyramids, reveal beliefs about royal afterlife and divine kingship. The Old Kingdom's end around 2181 BCE involved political fragmentation, possibly linked to climate shifts affecting Nile flood reliability, though this remains debated among scholars. Ancient Egypt's formation along the Nile established patterns that persisted for over 3 millennia, a degree of cultural continuity unprecedented in human history. Understanding this longevity requires examining both environmental and institutional factors. The Nile's reliability provided consistent agricultural foundation. Unlike Mesopotamian rivers prone to unpredictable flooding or regions dependent on rainfall agriculture with variable yields, the Nile's annual cycle created environmental predictability that supported stable institutions. Even during periods of political fragmentation, the fundamental relationship between river, flood, agriculture, and society remained constant. Ideological continuity reinforced institutional stability. The concept of Mat, cosmic order, justice, and proper balance, became central to Egyptian thought. Pharaohs legitimized their rule by claiming to maintain Mat, creating ideological continuity even through dynastic changes. Hieroglyphic writing, religious practices, and artistic conventions showed remarkable consistency across centuries. Archaeological evidence documents cultural resilience through multiple political upheavals, the First Intermediate Period's decentralization, Middle Kingdom reunification, Second Intermediate Period foreign rule, and New Kingdom imperial expansion. Throughout these changes, fundamental Egyptian cultural identity persisted. Later civilizations recognized Egypt's significance. Greeks, including Herodotus and Plato, studied Egyptian thought. Romans incorporated Egyptian religious practices. Modern archaeology continues revealing evidence of Egypt's innovations in mathematics, medicine, astronomy, and engineering. The story of how ancient Egypt formed along the Nile demonstrates how environmental circumstances, technological adaptations, and institutional developments interact to create civilization. Egypt's particular trajectory, from pre-dynastic villages to unified kingdom to enduring cultural tradition, resulted from specific geographic, climatic, and historical factors. The archaeological record continues expanding through ongoing excavations, remote sensing technologies, and refined dating methods. Each discovery adds nuance to our understanding while confirming that Egypt's civilization emerged through gradual, complex processes rather than sudden transformations. This documentary has examined the evidence as it currently stands, acknowledging both what we know and what remains uncertain or debated. Ancient Egypt's story continues inviting scholarly investigation and public fascination.